Welcome to Economics.com Point 2. In today's explainer, we are going to explore one of the absolute most elegant tools in microeconomics. We're literally going to learn how to map human satisfaction, and the crazy part is, we're going to do it without ever using a single number to measure it. As we go through this, I think you'll see just how beautifully consumer theory visualizes our everyday choices and desires. Let's get started.
Okay, let's jump straight into our roadmap. We are going to define satisfaction in economic terms, visualize some real data, lay out the assumptions of our model, do a little math with the marginal rate of substitution, and finally, lock in the unbreakable properties of these curves.
All right, Section 1, Defining Satisfaction and the Ordinal Problem.
So here's a really tricky problem economists face. How do you actually measure happiness? You can't just hook someone up to a machine and say, yes, you are currently experiencing exactly 20 units of joy. That doesn't work. In economics, we say utility, which is just our fancy word for satisfaction, cannot be measured in absolute cardinal numbers like 1, 2, or 3. Instead, it's ordinal. This means we measure it simply by ranking preferences, first, second, third. We don't need a numeric score, we just need to know what you prefer over something else.
And that leads us to our brilliantly simple solution, the indifference curve. Essentially, this is a graphical representation showing combinations of different goods that provide the exact same level of satisfaction. Think about it. If two completely different bundles of goods give you the exact same amount of joy, well, you don't really have a preference between them, right? You are mathematically and economically indifferent.
Moving right along to Section 2, Visualizing Data. Let's ground this theory in reality with something we'll call Nietzsche's dilemma.
It's super fascinating to see how we can translate human desire into a schedule. Let's say Nietzsche is consuming two goods, chocolates and ice cream. Look at combination A, 1 chocolate and 16 ice creams. Now skip down to combination E, 5 chocolates, but only 1 ice cream. For Nietzsche, every single combination here, A, B, C, D, and E, gives her the exact same level of overall satisfaction. She's equally thrilled with any of them.
And this perfectly illustrates what happens when we map that table out. We put chocolates on the horizontal axis and ice cream on the vertical. By connecting points A through E, we get Nietzsche's indifference curve. Anywhere she sits on that line, her utility is exactly the same. But you probably notice this specific swooping shape of that curve, right? To understand why it looks exactly like that, we need to talk about the rules of the game.
Which brings us to Section 3, the assumptions. Let's set the rules that make this whole economic model function.
Every model needs boundaries. As we just discussed, utility is ordinal. We're also assuming our consumer is perfectly rational. They're always trying to maximize their satisfaction. Now, to keep things manageable, we limit this little universe to just 2 goods, assuming the consumer's income and tastes are completely fixed. But here is the absolutely crucial rule. Preferences must be transitive, meaning if you prefer good X over good Y, and you prefer good Y over good Z, well, you absolutely must prefer good X over good Z. It's just basic logical consistency.
Okay, Section 4. Let's uncover the mathematical engine dictating our graph's shape, the marginal rate of substitution. The marginal rate of substitution, or MRS, is exactly what it sounds like. It is the amount of good Y you're willing to sacrifice to get just 1 additional unit of good X, while keeping your overall happiness perfectly level. The formula? Super simple. It's the change in good Y divided by the change in good X. Think back to Nietzsche for a second. To get her second chocolate, she was willing to sacrifice a massive 8 ice creams. But to get her 5th chocolate, she'd only give up 1 ice cream. Let's think about how this builds visually. Because Nietzsche was willing to give up fewer and fewer ice creams for each additional chocolate, we see what economists call a diminishing marginal rate of substitution. Basically, as you get more and more of good X, its relative value to you drops. You're just not willing to sacrifice as much good Y to get it anymore. This diminishing MRS is exactly why the indifference curve is convex to the origin. It bows inward.
Now, there are a couple of extreme exceptions to this convex shape. If 2 goods are perfect substitutes, meaning you really don't care which one you have, they are entirely swappable, the MRS is constant, giving you a perfectly straight line. On the flip side, if goods are perfect complements, meaning they literally have to be consumed together, like a left shoe and a right shoe, the curve becomes a severe L-shaped angle. But for normal goods, the curve is always beautifully convex.
Let's jump into our final section, curve properties. These are the unbreakable laws of the indifference map. Property number 1. The curve must always slope downward from left to right.
Why? Well, because we assume the consumer wants both goods. If you want to get more of good X and stay at the exact same level of satisfaction, you logically have to give up some of good Y, right? If you didn't give anything up, your overall satisfaction would just go up, and boom, you wouldn't be on the same curve anymore.
Property number 2, higher curves represent higher satisfaction. This is based on the idea of monotonic preference. Basically, a rational consumer will always prefer a larger bundle of goods. A bundle found on a higher rightward curve gives the consumer more stuff. More goods mean more utility. So pushing your curve up and to the right, that's the ultimate goal.
Property number 3. Two indifference curves can never, ever intersect. This brilliant little rule is what keeps the whole model logically sound. If two curves crossed at a specific point, it would mean that single point somehow represents two completely different levels of total satisfaction at the exact same time. It's a total mathematical contradiction. A single combination of goods can only give you one specific level of utility, period.
And finally, property number 4. Indifference curves never touch either axis. Remember our core assumptions? We are analyzing a consumer who is buying two goods. If the curve touches an axis, that implies the consumer is buying 0 units of the other good. That literally breaks the fundamental rule of our two-good model. So the curve can get super close, but it never actually touches the edges.
By pulling all these properties together, we get a ridiculously powerful analytical tool. The sheer genius of the indifference curve is captured perfectly in this idea. We don't need to put a number on happiness, we just need to know what we prefer. This simple map unlocks all the complexities of human desires without forcing us to measure the unmeasurable.
Which leaves us with this pretty provocative thought. If all of your satisfaction is really just a subconscious mapping of preferences, how predictable are your own daily choices when prices shift and your budget changes? That exact tangency between what you want and what you can actually afford is where consumer equilibrium lives, and that's exactly what we're going to explore next time. Thank you for watching Economics.com Point 2. Like, share, and subscribe for more.